Okay, so our final section of theory in this chapter is really just bringing the last couple of lessons together. So looking at problems involving non-right-angled triangles and adding in that layer of needing to make a decision between the sine rule and the cosine rule. Again, I want to emphasize that if the problem has right-angled triangles, you're not going to use the sine rule or the cosine rule, you're going to use SOH-CAH-TOA. Okay? Right-angled triangle, SOH-CAH-TOA, much easier. Non-right-angled triangle, you need to choose between the sine rule and the cosine rule. Okay, so let's have a look at this first example, which is not really an application problem, but having to make that sine rule, cosine rule decision. So calculate all unknown side lengths and unknown angles in each of the following. Okay, so in this triangle, we've got one unknown angle, okay, angle A, and we've got two unknown side lengths, side length A and side length B. Okay, so the angle's the easiest one because we've got two angles, we can automatically work out the third. We don't need sine rule or cosine rule to find angle A. Okay, so angle A is going to be 180 minus 70 minus 75, which should be 35 degrees. You can use your calculator to help you if you need, but hopefully you can do that. So angle A is 35 degrees. Alright, so then once we know angle A, we might want to think about what else we could find. So now I might focus on finding side length A because I've got the angle opposite, and so I could use the sine rule if I want. So side length A divided by sine of 35 degrees is equal to, now I'm going to use the 6 and the 70 because I've got that nice pair that'll be helpful with the sine rule. 6 divided by sine of 70. Okay, let's use our CAS to solve that. It's a length that's unknown, so we don't need any restriction. So A divided by sine 35 equals 6 divided by, 6 isn't the best number in examples, it sometimes looks like a B. 6 divided by sine of 70. And then comma A, solving for A, control enter. And so we know that A is approximately 3.66, one decimal place, so 3.7 centimetres. 35 degrees, we don't need to write as 35.0 degrees because it is exactly 35. There's no rounding required there. If we have to round, we give one decimal place. Okay, so now does my answer make sense? Okay, A is quite small, but equally angle A is the smallest angle in the triangle by quite a long way, so side length A must be the smallest side length by quite a long way. Okay, then we want to find side length B. So now that we know the other two side lengths, we can definitely use the cosine rule if we want, or we can just again use the sine rule, either way. So we can again just use sine rule, so B over sine of 75. Personally, I would be tempted to stick with the sine rule, and I'll explain why in a second. I'll write out the cosine rule equation as well, but I would be tempted to stick with the sine rule, and I'll explain why. So B over sine 75 equals 6 over sine of 70. This distinction between B versus 6. And again, using our CAS to solve, I might just edit my previous solve actually. So I'll just leave the letter as A, because that 6 over sine 70 is right. We'll just make this 75 here. Okay, so it says A in my calculator, but it's really the equation for B is one decimal place 6.2 centimetres. Again, that makes sense. Okay, B is opposite the largest angle. Okay, angle B and angle C are similar in size, so side length B and side length C should be similar in size, and they are. They're 6 centimetres and 6.2 centimetres, but B is bigger than C. So everything makes sense. Now, if you'd chosen to use the cosine rule, to find B, you would have set it up as B squared equals 6 squared plus A squared, which is 3.7 squared, minus 2 times 6 times 3.7 times cos of 75 degrees. And then that would have given you the same value. Now, the reason I would choose this over this is because the second option, the cosine rule, requires you to use your answer that you calculated here. So if you use it, you're going to have to be careful to use it precisely so that you don't create compounded rounding errors. But the other issue is that if you got A incorrect, then you're also going to get B incorrect if you rely on A. using the sine rule doesn't rely on you using any answers that you've calculated. It relies on you using the information that you had in the question. Okay, so that's why I would choose to use the sine rule, because it relies on the information the question gave me, not any of my answers. And then that means that just in case I made a mistake in any of my answers, it doesn't matter. It's not going to affect my ability to get this answer correct. So personally, I would choose to use the sine rule instead of using the cosine rule. But you would get to the same answer by using the cosine rule. Okay, part B, again, finding all angles and all side lengths. Okay, so this time we've got angle C here we don't know, and angle A. So it's not going to be as easy to find the angles as it was in the previous one. This time we know two side lengths though. Now some of you might be saying, oh, we can use Pythagoras to find the other side length. Now remember, Pythagoras is only for right-angled triangles as well, so Pythagoras doesn't apply here. Okay, so let's think about what we know. So this is important here, that pairing opposite, that's going to make the sine rule useful. So that would enable us, if we use the sine rule, we could use this 8 centimeters to find angle A. Okay, so let's do that first. So sine of angle A, sorry, we've also got a missing side length C that we'll need to find as well. So sine of angle A divided by length A, which is 8, is equal to sine of 22 degrees over the length that's opposite that, so 3. Okay, so let's solve sine of A is over 8 is equal to sine of 22. Oops, sorry, should have set up my fraction. Control divide. Control divide. Sine of 22 over 3. Comma A. We're solving for an angle, so we will need a restriction here. So given that, let's think about what we know about A. So we've already got 22 degrees in the triangle, so that means that there's only 158 degrees left for the other two angles. So I just did 180 minus 22 in my head there. So 0 is less than A, which is going to be less than 122. Control Enter. Alright, and in this instance we find that there's two possible values for A. Okay, so this presents us with a bit of a problem here, in that there's going to be two complete sets of correct answers. Okay, so it's important that you're clear about which set is going to work with which set. Okay, so A is going to be one decimal place, isn't it? 87.4 degrees or 92.6 degrees. Okay, so they're very, very similar. Alright, so if we think about the example where A is 87.4 degrees, alright, so that makes it an acute angle. So I'm just going to make it go slightly that way instead. Alright, so that is 87.4. This we know is still 22. This is still 8. This is still 3. And we don't know that angle or that side length. Or we've got the situation where that angle is slightly more than 90 degrees. So 22, this time 92.6 degrees up there. Don't know that angle, don't know that length. This is still 3 centimeters and this is still 8 centimeters. Okay, so now we need to think about, if A is 87.4 degrees, what does that mean for side length C and angle C? We'll have one set of solutions. Or if A is 92.6 degrees, what does that mean for side length C and angle C? Okay, so the angles are going to be the easiest thing to work out. Angle C is going to be 180 minus 22 minus 87.4. So in my CAS, 180 minus 22 minus, now I'm going to be a bit more precise here, 87.375293. Okay, so C is going to be 70.6 degrees. Okay. In this triangle, if angle A is 92.6 degrees, 180 minus 22 minus 92.6, so that gives me 92.6247707. That gives me about 65.4 degrees. Okay, so that's my two possible values for angle C. And then we can find side length C either using the sine rule now that we know angle C, or using the cosine rule now that we know angle C. So either way. Again, we could probably do it not relying on angle C if we use the cosine rule. Okay, so if using the cosine rule, we use this pair of information in the cosine rule, then we should be able to find angle C without relying on our calculated answers. Okay, and it should still give us the two. It'll give us the two values. So then we'll need to work out which one's which. So actually, maybe I'll stick with using my given angles so that I can work out which one actually goes with the angles that I've got. So let's use maybe the sine rule because it's a bit neater, it's a bit easier. So side length C divided by sine of 70.6 degrees is going to be equal to, let's stick with the 3 and the 22, side length 3 over sine of 22 degrees. In this triangle, it'll be instead side length C over angle C, so sine of 65.4 degrees equal to 3 over sine of 22 degrees. Okay, so let's have a look at both of these. So in this one, solving, control divide, C over sine of, and again I'm just going to type in a few extra decimal places there, 70 points, oh I can just go up and copy that, sorry. I'll have problems here. Now this is a bit of a CAS technique. If I scroll up from here, so I want to put this number in the sine function on the denominator. My cursor is currently in the denominator. If I press up to scroll up, my cursor now goes next to the C. If I press up again, I go to that answer. If I press up again 2 more times, I go to the answer that I want. If I press enter now, what will happen is that that answer will get pasted to the place where my cursor last was in the previous answer. So if I press enter, it's going to go up there next to the C where my cursor last was when it left that line. So either we just retype it in the space, or you can use Control C to copy your answer and then scroll back down here and use Control V, just like you would in a Word document, to paste that answer. Okay. Oh, sorry. Right, and then we want that to be equal to 3 divided by sine 22, comma C. Alright, so that gives us C is approximately 7.6 centimetres. The other equation, this time it's the same equation, except we just need to change that 70 point whatever angle there. Let's delete that from there. Let's scroll up here. Let's press Control C to copy that number. Let's scroll down here and press Control V to paste it there. Control Enter to get an answer. And so in this case, C will be 7.3 centimetres. Alright, so therefore we can have angle A equals 87.4 degrees, angle C equals 70.6 degrees, and side length C equals 7.6 centimetres. Or we can have angle A equals 92.6 degrees, angle C equals 65.4 degrees, and side length C equals 7.3 centimetres. Okay, so one pair or the other. It's really important the way you present that answer. You can't just say A equals this or this, C equals this or this, and lowercase c equals this or this, because only one particular combination of that information will be correct for the triangle. So you need to be clear about the fact there are two completely correct sets of information. Okay, completely different sets of information that make the triangle true. Alright, so a bit more work than expected there, given that we got two possible triangles. Okay, example 2. Calculate the size of the smallest angle of the triangle whose side lengths are 30 millimetres, 70 millimetres, and 85 millimetres. Okay, so let's have 70 and 85 and 30. We want to find the size of the smallest angle. So again, thinking about that idea of how do we know which angle will be the smallest one? Well, it'll be the angle that is opposite the smallest side. Okay, that opens out to the smallest angle and so therefore produces the smallest side opposite. So that's the angle that we're trying to find. Okay, sine rule is not going to be useful to us here because we don't know any angles. Okay, so we need to use the cosine rule, which means I'm going to need cos of theta on the end of the equation here, which means I need to use 30 on the left-hand side of the equation here. Alright, so it's going to be 70 squared plus 85 squared minus 2 times 70 times 85 times cos of theta. Alright, let's go to our CAS. Solve 30 squared equals 85 squared. Oh, sorry. Well, doesn't matter. But I wrote 70 squared first. Plus 85 squared minus 2 times 70 times 85 times cos of an unknown, whatever letter you want to use is fine, comma x. And then because I'm solving for the angle, I need the restriction. So given that, and we don't have any other angles, so we only know that the angle has to be somewhere between 0 and 180. Control Enter. And we find that theta, the smallest angle, is approximately 19.1 decimal place, 4 degrees. So if you found that your smallest angle was 100 degrees, that doesn't make any sense. Okay, the smallest angle surely is going to have to be less than 60 degrees to make sure that the other two angles can both be bigger than that. All right, so thinking a bit about that, does my answer make sense moment again? Okay, last example. We have to come up with the diagram ourselves. So two hikers, Alphonse and Bernard, start at the same position. Alphonse sets off from his position on a bearing of 20 degrees true, and Bernard sets off on a bearing of 315 degrees true. After walking a distance of 300 metres, Bernard realises that he can see Alphonse at a bearing of 100 degrees true. How far apart are Bernard and Alphonse at this moment? Give your answer correct to the nearest metre. Okay, let's sort of think about our compass points just to help us work out in which direction they head. Okay, so let's start here. That's the same starting position. Alphonse sets off on a bearing of 20 degrees. Okay, so he sets off out this way, where that's 20 degrees in there. Bernard sets off on a bearing of 315 degrees. Okay, so 315 is 45 less than 360. So that's going to be sort of exactly halfway between north and west. So he's heading off up that way. Okay, so 315 the whole way around that way, or that's equivalent to saying it's 45 degrees around this way. After walking a distance of 300 metres, Bernard realises, so which one was Bernard? The one going at 315, so out to the left. Bernard realises that he can see Alphonse at a bearing of 100 degrees true. Okay, so let's just think about a bearing of 100. So 100 is just a bit more than 90, okay? So that would sort of be a bearing of 100 degrees. So, what we want to do is essentially think about, all right, where does, I'm just going to move my diagram bit down a bit because it's, what I'm interested in is actually up the top there. Okay, so what's happening here is, oh, sorry, change the colour, how exciting. Okay, what's happening is Bernard's going to get to some point, let's say he gets to here, so that when he looks back on a bearing of 100 degrees, which if you just look at my little diagram over there, sorry, it's not a very straight north line, is it? It's going to be a bit further than 90. So when he looks back sort of out that way, so that that's 100 degrees, he can see Alphonse. Okay. All right, so let's sort of solidify what we've got happening here. So that's Alphonse there. Okay. And that's Bernard out there. And that's our 100 degree bearing, and so that's going to be the line joining them. All right, so we've got some angles. We do know some lengths as well, I think. Yeah. After walking 300 metres, so Bernard had walked 300 metres, so that's 300 there. He can see Alphonse on a bearing of 100 degrees. How far apart are Bernard and Alphonse? So this is the length we want to find. that side length of the triangle there. Alright, again, not a right-angled triangle, so this isn't about SOH-CAH-TOA. Alright, so let's think about what we do know here. So if we think about, and there's a number of different ways we could go about doing this, and there always is, it comes down to sort of being able to use your angle properties. These green lines are parallel lines, okay? Which means that this 45-degree angle in here and this whole angle around here are co-interior angles, okay? So co-interior angles. So co-interior angles sum to 180 degrees, okay? So if we've got 45 down here, 180 degrees means that this would need to be 135 up here. So this green angle is 135 degrees, which means that we can work out that in the triangle, given that we know the bearing's 100, that must be 35. Okay, so we needed to find a way to use that 100-degree bearing. Okay, and one way to do that is to use the co-interior angles with the 45-degree angle, and then we can work out that that's 35 up there. Okay, so let's be clear about what we've got here. So in our triangle, we've got, at the bottom here, we've got a 65-degree angle, 20 plus 45. Up here, we've got a 35-degree angle, okay? Here we've got 300 meters, and this is the length we're trying to find. Alright, so we could use the sine rule if we knew this angle over here, and we can work out that angle over there by doing 180 minus 65, minus 65 and minus 35. 65 and 35 are 100, so that leaves us with 80 degrees. So that's 80 there. So then we could use the sine rule. So that would be x over sine of 65 degrees equals 300 over sine of 80 degrees. You couldn't use the cosine rule here because you need to know at least two of the lengths to use the cosine rule, and we only know one length here, so you have to use the sine rule. Okay, so let's solve that. Menu 3.1, solving x over sine 65 equals 300 over sine of 80. And comma x. It's not an angle, it's just a length, so we don't need a restriction. Control Enter. X is approximately, we want our answer to the nearest metre, 276 metres. Okay, so today's work is from a worksheet, a mixture of worded problems and just basic triangles like you saw in the first example, but where you need to make those decisions about sine or cosine rule, which is going to be better here. Again, can I remind you, if there are any right-angled triangles in the problem, we're not using sine rule or cosine rule, you're going to use SOH-CAH-TOA.